Good morning. I'm Jeff Hammond, Executive Director at International Ground Source Heat Pump Association. Thank you so much for joining us for the August Dig Deeper. This Dig Deeper is sponsored by Subterra Renewables. Subterra was one of our gold sponsors at the 2023 conference, and that was one of the perks of being a sponsor of the conference, was also to have a sponsorship for Dig Deeper and Town Hall webinars. So we'll get started with this August session. Before we turn this over to our speaker, Brock Yordy, we have some IGSHPA news just to get everybody up to date on what's happening. If you'd like to speak at one of these town halls or dig deepers, just simply go to the training and events button on the home page and you'll find an abstract form. We do have 2 left, I believe, for the rest of the year. So you'll want to act pretty quickly on that. If you haven't heard already, our next annual conference has been pushed back just a few months so that we have a spring conference instead of a December conference. And this one will be in Champaign, Illinois, in conjunction with GAOI, the Geothermal Alliance of Illinois. So everything is moving quickly with this conference. You can see from my graphic about 50% of our rooms are already sold out. We do have other hotels in the area, but if you want the convenience of just walking from your room to the convention center, staying at the conference center is very, very convenient. We're accepting abstracts for workshops through November. Our early bird registration is through January 31st, and we also have sponsorship, exhibitor opportunities, conference program advertising, and even a new app with conference sponsors. We already have quite a few sponsors. Thank you very much. We could not do the conference without these sponsors each year, but we have quite a few left. So if you're looking at getting your name out there, as you can see, we have a lot of companies' names on the screen. This is a great way to be announced at every town hall, every Dig Deeper, and also in our mailings and so forth about the conference. We're also filling the exhibit hall. We have 2 areas. There's the inside space that you're seeing on the screen right now, and we have an outside space for heavy equipment. Again, you can see here there is a limitation of space. So if you want to exhibit, you want to check that out. Hopefully you saw towards the end of July the Geo Outlook magazine. If you didn't see that, please let us know. We have had some incidents where email subscriptions have been, they've been unsubscribed, in fact. So if you're not getting IGSHPA emails and you didn't see the July Outlook, Geo Outlook, make sure you let us know. If you're planning to write an article or you'd like to advertise in the next edition of Geo Outlook, our next edition is in January. We're working with BNP Media, which I'm sure you're familiar with if you subscribe to Engineered Systems or the News or the Driller. They're just great to work with, but it gives us quite an outreach from our 6,000 that we have in our database and their subscribing base. We end up with about 50,000 potential readers of Geo Outlook. So check that out if you haven't already. Our new membership program that started at the beginning of the year has a lot of new levels. If you're not already a member, we have lots of different ways that you can join IGSHPA as a directory-only listing or all the way up through benefactor members. We also have new rates for students and retired persons, community organizations, and so forth. That's on our website at IGSHPA.org. There's a new member portal this spring that launched, and that's got a lot more information. You can see your certifications, your membership expiration dates, and so forth. So check that out if you haven't already. If you haven't logged in a while, you may have to reset your password. We could really use your help on our new databases. We have 2 under that geothermal menu that you can see on the screen. One is project databases, and one is licensing and CEU requirements. There's a form on those 2 pages that allow you to submit information. We're really trying to build this out. This is super helpful in providing more information about our industry. There are so many jobs out there that people just don't know about. Likewise, as more people come into the industry, we need that licensing and CEU requirements. This is phase 1. Phase 2 will be searchable databases. For now, we have links on the pages, and we could really use your input. For CEUs, we are offering CEUs for this webinar, Dig Deeper, and also town halls. Just simply send your name and email in the chat, and we'll record those. We also have a relatively new option. We've been doing this for about a year now. If you're watching this recording, simply provide this code for this specific Dig Deeper webinar and send your name and email address to info@igspa.org. If you're live, don't worry about this. All you need is your name and email in the chat. But this is for being able to get these CEUs if you're watching a recording. Just a quick question for members. One of our Diamond Spin sponsors from last year's conference had asked about a scholarship opportunity for students entering our industry. We definitely need more and more people in the industry as it grows. The question is, for members, would you be willing to contribute to a scholarship fund? Also, it would be great to have some information on how you think that might work. We would coordinate that fund. So if you could provide any comments, send them directly to me, Jeff@igspa.org. We would love to have that feedback. A little bit of housekeeping here. Brock, as I mentioned, will be speaking shortly. If you have any questions, just submit those in the chat or the Q&A, and I'll read those at the end of his presentation. We will be recording this as well, so you can review that discussion. We have had some challenges with some attendees' security settings. So if you can't use chat, you might get a message that looks something like this. Just click OK, and that will allow you to use the chat feature. If you can't use chat, there's also Q&A. And worst case scenario, raise your hand and we'll unmute your microphone. So hopefully you'll be able to ask those questions, but these are just some potential options. All right, so we're just about ready to introduce our speaker for this webinar. Before we do that, I do need to read this disclaimer and potential conflict of interest. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA Town Halls and Dig Deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is a presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. So with that, I'm thrilled to introduce Brock Yordy, and I thank Subterra Renewables for sponsoring this Dig Deeper. Brock, feel free to share your screen whenever you're ready. Let me announce Brock. He's with Geothermal Drillers Association, and Brock's journey in the geothermal industry began in the 90s as a third-generation driller for his family business, Yordy and Sons Well Drilling. His dedication to the industry led him to Western Michigan University, where he studied groundwater science and environmental policy. Post-graduation, Brock's commitment to excellence pushed him to Halliburton's drilling fluids and drill engineering program to become a mud engineer for Bayreuth IDP. His eagerness to learn and grow led him to volunteer for challenging, often failing drilling projects worldwide, to experience every drilling condition, situation, and application available. Brock is the co-founder of the newly formed Geothermal Drilling Association. He's the creator and anchor of the Driller Newscast, which airs weekly on Monday mornings at thedriller.com. You can also find Brock's technical papers, articles, podcasts, and videos at thedriller.com under the same publishing company as Engineering News, Record, ENR, and the News, HVAC Magazine, which are all part of BNP Media Group. Thanks so much, Brock, for presenting today. I'm anxious to listen to your presentation.
Hey, thanks everybody. And I want to give a shout out. Robert Meyer, the co-founder of the Geothermal Drillers Association's on. And as we jump into this, late last week, I got a phone call that said, "Hey, Brock, whose projects are you going to talk about?" And it hit me from before Ball State to now that there's lots of projects and we've had lots of successes and we've had some stumbles and whatnot. And this isn't to be a call out one discipline over another or whatnot. We as a drilling side of this industry, it's very important with the collaboration and how we work and technologies and how we overcome. And so as we had this great hour discussion, It isn't about, oh, can I figure out where we're talking about? We're gonna do the overview, look at a slide on what has happened, and from before drilling starts through drilling. And obviously, we're not going to get into engineering or the mechanical side of it because it's not my wheelhouse. But I really appreciate the opportunity to talk about this. And the last 10 minutes, hopefully, we're able to unmute Robert Meyer as well, and he can speak. And we really appreciate, we're proud IGSHPA members and have been. And damn, I love this industry and what we get to do.
You're muted, Brock.
Okay, somehow I muted myself. I love this industry. I am a geothermal fanatic. So before these projects start, what are we thinking about from our preparation, the data, the feasibility, to project expectations through completion, contractor collaboration, because we always have more than one party involved, from a client to a GC to an engineering firm to a drilling firm. We talk a lot about vertically integrating, and Kareem with Subterra, as many times as I've had opportunities to listen to him and also moderate some panels, it's been a big talk of how do we shorten the timeline of decision makers. And it comes down to that contractor collaboration. What processes are we going to use? What equipment and tools? And again, identifying all parties involved or impacted. And Western Michigan University, I also got an opportunity to do a lot in production and film. And I love George Bernard Shaw, but I think about this often as I start projects. The single biggest problem in communication is the illusion that it has taken place. So where do we start? What does your process look like? From a driller, from a HVAC contractor, from an engineer, what are we looking for? What is that location? What is the feasibility, budget, stakes? I just saw a few weeks ago when I was in Manhattan that, the thermal networks that were supposed to be ramped up and getting really started by the end of this year into next year have had some more due diligence, and the phases are now talking 2026. So, what is that feasibility? What is the budget? What is the stakes from hitting our 2030 goals to new laws, regulations, into what are our state laws and regulations? Next, test holes, logs, data. What can we get out of the drilling phase before we start? Again, that runs right into our bore field size, hole specifications, construction timeline, and contractor qualifications and capabilities. As a third generation son of a proud drilling company owner, working for many different drilling companies as a consultant or a leader, when I was with Suez North America as director of wells, we very much, as we selected municipal water wells, which now have a life cycle the same as what we think of as a loop field, 60 to 80 years, what was my selection process like? Equipment availability, location history, data, geology, test logs. Who's my customer? Who's my engineer? Hole specifications, product installation, specifically here, loop installation, our grout, our timeline and staff, site management, and finally, what other project commitments? Because let's face it, as we get out there and educate from big projects to little projects, things are getting pushed back, weather's impacting pieces, projects aren't starting when they're supposed to, and it's, do I have enough time to effectively execute and make it to my next commitment? I love this photo. This is Kevin Austin's photo from 2009. This is Ball State University Phase 1. And, we are well underway on the South Field, and the North Field was kicking butt as well, heading towards 1,800 holes. And this was a big deal because we hadn't undertaken something like this at this point. And as you look at this sheet with the different color codes, what can we identify here? What issues do you see? Sorry, everybody. Am I okay? So, common project issues that I've experienced over the past 20 years when it comes to consideration. What's one that has really reared its head in the last couple? Weather. From extreme heat to limited work days to 100-year storms that are no longer 100-year storms. Next, sharing that site. What other construction operations are happening? How do we maneuver that piece of equipment? How do we move solids? Local regulations. What do we have there? What have we gotten into with Gen X chemicals or PFAS? You know, Location. We're looking at a lot of urban drilling that's not just universities and schools where we have lots of property and people are excited for that cost to drop. But now we're inconveniencing homes and businesses. We can see with the Inflation, not the Inflation Reduction Act, but the federal infrastructure law that roads have been tore up and people are sick of this. So as we get into these larger projects, how is that impacting our timelines? Right into project timeline. And when I think of location, I think about before I start drilling, what obstructions am I about to hit? Who are my neighbors? Just last week, I was in Jamaica Plains at a school, and as we were having discussions with students about drill rigs and whatnot, a neighbor came over and very colorful language for Boston explained how upset she was with the noise and when was this going to stop and that it ruined the summer. And, again, who are we impacting? And if it's across the street and it's not part of their thermal network, do they see the value moving forward? Site size. We just keep trying to pack in as much as we can. And that comes back to our site management. So weather, as we put these Gantt charts together and we start thinking about how many feet a day can I drill, how productive can I be so that I can reduce those costs and move, I want you to think about this drop to the first August 8th, that there's been $19 billion weather impacts this year. I think there was 34 last year. But as we think of a 100-year storm is now 5% more likely than what it was. How does that change our job sites? What is our extreme weather plans from lightning to rain to how do we handle this with our people, our processes, our equipment, and how does that shift our timeline out? This was a project on the right there was October 1st, downtown Chicago. And we had expectations to mat the project, but did I think on October 2nd, we'd pull in and it would be covered in snow? We had weather apps that said it was going to get cold and we had to drain some things, but no, it took us a good majority of that day to get that rig back warmed up when you start thinking about hydraulics and all the things that change us from being able to get one full hole or, depending on our depths, maybe 2 or 3 holes a day in that shift. So as I move past weather and I start thinking, and shout out to the Midwest Geothermal folks, as I worked with them on several projects in 2018 and 2019. They're right up the road from me, and I've known Scott and Courtney and Tony for a very long time along with that team. And so I have some photos in here, and this was George Lucas Narrative Arts Museum. And we had to share the job site with the forms that were being poured for the earthquake mitigation. There was lots happening for them to meet their timelines with liquidated damages for expectations on many pieces. So as we start sharing that site, we think about all the great work that happened at One Java or in Framingham. What are our hazards? What is the fall path of my rods? How does that stop from being able to set forms or other things happening? Who has span of control? As I worked for Suez North America, we were on a project where they were rehabbing the water tower at the same time. An individual fell, broke their back, and later died. I lost control of that drill rig and grouter and all the support equipment for 8 weeks as the investigation happened. So again, as things are happening, we have to be able to consider that. And if I hadn't been a behemoth company, could I have afforded to lose that piece of equipment that should have been making $7,000 to $9,000 a day if I was effectively doing it right? What does my emergency action plans look like as I'm starting to think of triage and moving equipment in and out of sight? Location, our site sizes, we're trying to fit as many places as we can. And we got great technologies with utilizing waste heat and this whole holistic idea that we have. But man, what else are we getting into? I like to think of, as I pull up on site and I look at that green space, should there be a Starbucks there? Because if it's a green space and it's a park and we can't decide with all the rest of the property around there being high value, what did my greatest generation grandfather bury there that I'm now concerned about? So as I start looking at that location, I'm considering how my equipment's moving in, how that's going to impact my cost and timeline, what hours of operation, what regulations, site management. Again, in order for us to scale and hit 2030 goals, we're back to, are we being neighborly to everyone? What regulations do I have for site waste removal? How does that have to be handled? What does the environment look like for that job site? What are my natural obstructions? What are my man-made? I've had this cut out forever in my office, and this was 2014, and this was from The Guardian, and New Yorkers up in arms over geothermal drilling. If I lived next door, I'd blow my brains out. What a slap in the face. And this was shortly after Sandy, and those who could afford at that time to put in a good geothermal system, you know, took it beyond them. But if you start reading the quotes from the neighbors, and if you pull up this Guardian article, our chairman of the board, Jack, is got on there and talked about the value of geothermal and what's happening in New York City and what can happen up the coast and the resiliency, and that was 10 years ago. And you think of where we are now, and you think 6 years before that was Ball State, but our urban markets and our neighbors and who we're impacting, is a big deal. And as you see them talking about trees, I just talked with Purdue University, which has a big arbor program, about some things they were looking at. And again, they were worried more about equipment impacts than they were about drilling. So, how do we become the right neighbors and we continue to have that positive piece that doesn't have cost overruns to us? Project noise mitigation. This was a noise study I was involved in, about a decade ago. And obviously, this is a mud rig, and you can see that's a big piece of equipment. And you can see around that compressor and that rig were 97 to 105 decibels. Hearing damage at 105 is, within 30 minutes. 90 to 97, you're permissible at, 4 hours. So as we look at this, you go, all right, Brock, we got better equipment. We got European equipment. We have all of this. We still are running these 1600 and 1300 CFM compressors at very large volumes. And so as we break connections, do we have a diffuser so as we have that big degassing moment that is blowing 105 decibels across the job site, I suggest from an engineer to a project manager to a drilling company to download the NIOSH OSHA Sound Index app. Most of our smartphones right now are calibrated adequately, but really we have to start thinking about sound barriers. And we put up some good sound barriers, but when we consider a compressor sitting up out of the mud or where it's positioned, is our sound barrier able to block that, or have we still created an echo chamber? And from University of Michigan last year to the projects in New York and Boston, things we have at universities, obviously noise mitigation is crucial. And as we do more angled holes and hammers, and we run big air to be able to have that 5,000 PSI, we have to understand that impact and what that cost is. Natural obstructions. I'll go fast through this, but this is Minneapolis. And by the way, Minnesota has a state bumblebee, rusty, not a good insect guy, but it's rusty something bumblebee. We pulled up on a job site to start after the test hole was in. Site was covered because it was a green space and they had put clover in for the bee. We could not start. Nobody had had a consideration on that, but it was a protected species. And I know there's that time where we go, they're just bees, they'll move on. But again, somebody cares about that, and that shifts our cost, our timeline, everything. That's the same with trees, wildlife, landmarks. As we go into some of these green spaces and urban areas, what is the historical significance to those trees as we move track equipment or rubber tired equipment? What do we need to do to mitigate that? And that all comes with cost. At whose cost? As we start talking about drilling being 70% of the total project cost, what are we going to do there? Obviously, overhead obstructions, big deal. Right of ways, for me, as I'm starting to consider a job site, I start standing in that bore field and I look up. It sounds silly like Dr. Seuss, but before I can drill down, I need to look up and around. Subsurface man-made obstructions from the Rust Belt cities. It's crazy to see where we lose our underground utilities, not quite knowing where they are, to abandoned structures that have been buried. Chicago burned down twice, and we saw that with the Obama Library, that there were some cost overruns there that we could have had a better idea. But the big thing for me, again, comes back to these reclaimed areas. Why isn't there a Starbucks there? Why isn't there a new, beautiful high rise of high end homes? Was that a dump? Was it a junkyard? Was it a drain field? What hazardous waste is this been bermed up the way it is? And I know we talk often that we can drill through a Superfund site and not have an issue. I want to talk decontamination cost. I want to talk about all the rest of the pieces of us being able to mitigate that job site, because those are all costs that somebody's going to have to recoup. Commute to the project. Garrett Carino with American Drilling says it best. Brock, man, I love working in the city, but dang it, does it increase my work by about another 30% from being able to bring that equipment in, from being able to get that vac truck in and out. All the things that happen will slow down our process. Test hole operator site assessment. As we start looking and we do that feasibility before we have that drilling company, I think it's important for us to look at where we're considering that test hole or holes. And I want you to start looking at branches and pieces. Is this something that we're going to be able to get permission to, clean up the area to be able to get that piece of equipment in? Is this still a feasibility study and they want the least amount of impact possible? But this is where getting your driller, getting your contractors involved and their insight is invaluable. Understanding all the impacts that will be involved. Drilling's disruptive, everybody. We know it, from air to mud to sonic to reverse to casing advance. We are opening back up Mother Earth that didn't want to be open. So as I jump into drilling operations, and man, does this move out? What impacts my cost and success? If I jump to the top in green, the natural subsurface conditions should not be something that's bothering me. I can choose the right drilling method. I can choose what I'm going to have for drilling fluids program. I can mitigate all of these, from reactive clays and shales to rock to dense rock to gravel and sand. This is not an issue. What are bigger issues for me? Again, those subsurface obstructions and contaminants, where I have to haul off the 5.5 cubic yards of material per borehole that I just removed out. What utilities are there? What old building, dump, industrial pollution, and then as I get into drilling companies, we should be able to overcome these things. The problematic subsurface conditions, I'm thinking about cobbles and boulders. As I get into the lower Floridian, talk a lot about being able to utilize, thermal networks and systems. I got lots of cobbles and boulders and lost zones down there that is going to take a much more strong drilling program. Water, depth to water, high water production zones, wellhead protection areas are all big considerations that end up increasing cost. And these are things that in the front end, we have to have a consideration on. Finally, artesian flow, methane gas, H2S, volatile gases. We have plans in place, but again, this is where the test log and having the right notes, looking at the area history and saying that I can mitigate these risks, I can hold back that methane and trap it with the right grouting program. We have to be considering those as we get into the drilling phase and what that could cost. So we get through that big Gantt chart. What am I thinking about to mitigate these risks as a drilling company? What is my drilling system? And it starts with defining that subsurface conditions. What is my geology? What is my formation hydraulics? That is the amount of energy I can exert on that formation and be able to successfully drill that borehole at a good rate of penetration, continuing to have good production. What is my depth of water? How is that going to change? What can happen if I'm producing a lot of water? What happens when I supercharge that borehole? I bring all that sediment out because I'm able to use big air. We're capturing it in Baker tanks, and then we're releasing it at the right NTUs. What did I just do to that test hole? What did I just do to that bore field? What subsurface challenges could I be about to encounter, and how am I prepared? And that puts me right into drilling capabilities. And that's where we see all sorts of different rigs, methods, where we're getting into this. And it's what is my rig's horsepower? That's going to determine my depth and my angle, what I'm capable of doing. What is my rotation to being able to cut those geologies, to be able to bring those cuttings out of the hole? What is my pull down force, allowing me to give angle when I need angle? How am I able to keep a straight gauge hole? Pull back again as we start looking at engineered systems, and I start moving from this to a municipal water well to back to oil and gas. What is it going to take? What is the drag? What is the friction loss that I have there? And then obviously with pullback, my bottom hole assembly, that's going to give me the rigidness to prevent deviation. Good vertical drilling companies all over the country have been able to drill effectively without a bunch of bougie oil and gas technologies. And I love our oil and gas technologies and all our influx we have. But back to drilling 101, we have a good bottom hole assembly. We have good weight on bit. We're able to get good penetration rates and stay within our deviation tolerance. And finally, with those rig capabilities, that's what's going to give me my diameter, my depth, my angle. Now, as I move over, I start considering what method am I going to use? And that can be from traditional mud rotary to my air. What do I have for compressor? My sonic and those fragile formations on top, or through that garbage, to dual rotary, to reverse circulation, casing advanced. Again, what is my tool in my toolbox to prevent my cost overrun? Mind you, as we get past the traditional conventional rotary and we get into sonic, dual rotary, reverse, those all cost more due to tools, techniques, training. And finally, who's my qualifications to my driller? What tools do they have? What methods? What can they show? How are we controlling where those solids go? How do we dispose of those solids? How are we applying the science and fundamentals? So, test holes. I want you to think to yourself right now, why? Why do we do test holes? For me, it's to discover the unknown so that I can have a better, broader description. But we're doing it to gather that data from the unknown. We're doing it to define that subsurface. To do this, it isn't a how fast can I drill this borehole and have a semi-good log. I truly, in order to prevent these costs and overruns, I need a good subsurface idea of what's happening. So for me, in mitigating these risks, cost overruns from a test hole, what are my sample intervals? Am I sampling every 5 feet? Am I sampling every 10 feet? I just had an engineer go, Brock, what do you mean we need to sample every 10 feet? I go, okay, if we're not going to sample every 10 feet, I need to know every significant change. I know I'm making a rod connection change every 20 feet. but I also know the time it takes for cuttings to come out of the hole and to have a representative sample. So it is not about production drilling. It's about defining that borehole in a gauged idea. So what is my sample size? What do my cuttings look like in my log? Size, color, consistency. Am I going to have a geologist on site, or am I dependent on catching these samples and being able to pass them on? What is the depth of my significant changes? Depth of saturation zone, where I'm going to start producing water, or we know that that formation is now saturated and is going to react differently with my drilling method. What confining layers am I going to encounter? Each time I pop through that confining layer, I'm changing where my static water level is, what my porosity zone looks like, how much fluid we could be producing out of that hole. What is the thickness of each one of those? Depth, length, resistivity of a loss zone. Depending on where we are in the country, we get that, hey, Brock, the rod's just dropped 3 feet. That's a significant thing to note. And that's something that will help us have a do not exceed price versus a, hey, it's time for a change order. What does my drilling fluid monitoring look like? How's the color change of that fluid? From the colors of the cuttings coming out of the hole. What is that density in pounds per gallon? How are those cuttings affecting hole cleaning capabilities? And then change in penetration rates. How much more time is it taking per rod? What does my rotational torque look like? There's plenty of things that a rig from 1984 to a rig in 2024 can tell us, and a driller with a good notebook and a detailed log beyond what we're getting in our science pieces. And that moves us to post drilling, having that deviation log, running a geophysical log with a caliper, resistivity and gamma. That's going to be able to take those cutting samples that I have and compare them to what I'm seeing in porosity zones, to those confining layers. When I get into product installation on that test hole, was there an issue with hole cleaning, and we have a big dense fluid and we're not able to get that loop in as effectively? Or are there points where we transition from shale into a limestone ledge and we're hitting on those? And now we're considering that 1.25 loop versus the 1.5 loop in depths. Obviously, the deeper we go, we've now moved to a more rigid 1.5 loop that's catching, that we're having more issues fighting. We have to understand those transitions and have those notes. Grouting, what was my theoretical plus that 15-20% versus actual? So I know the damage that I've done there, which again, I can go back and look at my geophysical logs. Then after completion, I can finally get that thermal conductivity test and have a good picture. We talk about 70% job cost for drilling or more. We talk about drilling being too expensive, but then we start putting these parameters in to prevent those cost overruns. And we say, man, Brock, you just made us an insanely expensive test hole. And then I'm going to say, what is my representative sample of 4 test holes versus 800 boreholes I'm about to put in? Should it be 10% of the bore field should be a test hole? If we're going to define this industry and be able to have a better idea of what we can get for engineered systems and the best performance using the earth as a battery, is having the control to be able to compare to the production. So drilling process, what am I looking for my keys to success? Borehole design. And that's going to change the amount of grout. It's going to change the annulus, my uphole velocity, all the pieces in mitigating the damage to that borehole or how it's going to be straight. And then I'm going to apply that borehole design and look at my geologic conditions from that test log and select my right drilling method. Then I have to start considering the transitions of those formations and those solids that I'm going to have to remove and dispose of. And then how can I do that from 1 time to 10 times to 100 times to 1,500 holes? So as I look at drilling methods and uphole velocity, mud rotary has given us pretty slow drilling with minimal impact, other than we have considered that it's this big, thick drilling fluid that I need to get rid of. When we have solids control, there's plenty of pieces there. There's a lot of good applications for mud rotary out there and how we use it to mitigate the amount of water we're producing out of the ground. Obviously, air rotary in ideal conditions is beautiful. 3,500 feet to 7,500 feet per minute uphold velocity. I'm getting instantaneous cuttings results. With big power comes big responsibility. With great power, Stan Lee, Spider-Man, think of it. So as I look at straight air to air water, drilling additives or downhole hammers, what is the damage I'm causing from a very laminar flow mud rotary at 150 feet per minute, 200 PSI on the bit face versus what I can get into? I want to air rotor every chance I can, but there's obviously places. And then as we start looking at additives, that's how we can manipulate and slow that hydraulic head and that force and what we have happening. And finally, we can get into alternative methods of reverse circulation, casing advance, and sonic. It's going to slow down our cuttings removal, our penetration rates. But if I have a small site and I need to consider how I maximize every one of those boreholes and I have great success, what is the cost there? So we looked at this, and this is the impacts. Now, how do I apply those with my drilling methods and thinking about problematic projects, from cobbles and boulders making us lose holes or not get loops in, to high water production and how we are able to treat that and pump it out? So I'm going to go back and go dummies guide to drilling in geology. And you would think sand and gravel, hell, there's no issues. This is cake. And we've been doing it in the Midwest, and this is why it's so easy for us. But what are my concerns? My concerns are the damage that I can do. No different than if I'm at the beach, Labor Day weekend, and I start digging that big hole with my kids to make them a makeshift well, and what happens? It keeps caving in. What is my stability in those porous materials? What does my erosion look like? How does that affect my product installation from getting those loops in? What is the impact to a soft, fragile formation? Then I think about rock. What type of rock am I about to get into? What type of solids size? And that's going to determine if I can drill a 5.5-inch borehole, if I drill a 6.5-inch borehole, and how I can get those out. What is that density? How heavy is it? What erosion can I get into when I transition from a dense rock into a sandstone or something that with that same force, I don't realize the damage I'm doing? Determination of the penetration rates, and then tooling wear. Again, rock, sand, and gravel, they don't react, right? They're not like clays and shales that swell, get sticky, start to change the borehole after we've tripped out, in shrinking, but we have to consider those. So choosing our right drilling method and minimizing our impact is key. There's some reactive clay right there. So as I start thinking about clays and shales, how do I steer in them? What happens with differential sticking or plugging bits, cutting size? What does my rotation look like? Obviously, the least amount of water I can give a reactive formation, obviously drilling with air, the better that these don't happen. But as that happens, how can I prevent them? How can I prevent that reactivity? This is what a good inhibited clay looks like. I can break that open in the middle. It's dry. I can run a foam on it. I can run straight air mist. I'm going to be hydrating that, and we're still going to see some sticking and swelling. Borehole fluid density. And last year I did a talk on solids control, so I'll go right through this. But what is our expectations as we look at that dense fluid? And are we recirculating 5% solids? We're recirculating 21% solids. And the deeper we get as those formations change and they become more fragile, or there's a point where we could break a fracture gradient and lose fluid, destabilize a hole, I want you to think about the PSI of head of a 10-pound drilling fluid. 10-pound drilling fluid at 100 feet is 52 PSI. At 300 feet, it's 156 PSI. What do you think it is at 600? Air rotary, love it. I love it. Straight air, air water. As I look at it, I have great penetration rates in the right locations. I get good results. I can overcome many problematic issues with reactive zones to fragile formations. If I augment to a foam, to lost circulation zones, I don't have the hydraulic head of a drilling fluid that is dense. But what happens when I hit 5,000 CFMs of air into a high porosity zone? How do I capture that? How do I remove that? And what is the sediment I'm moving from that formation out? So as I think about just straight air, I can move to augmenting foams. And I implore you to go talk to your mud engineers and look at different things. And now you're thinking foam, great. We're gonna have this big, instead of drill mud, we'll have this big foam party going on. Nobody enjoys that. In reality, we can put that into a stuffing box the same way as a hammer. We can hit it with a defoamer that can be apple vinegar at some points. It's just changing the surface tension of that bubble. There's plenty of things we can do with air foam that will help us be able to slow that impact to those fragile formations. Downhole hammers. We love them. We're using them a lot all over the country. What do I need out of them? I need adequate differential pressure to make that hammer work. I need to have good bottom hole velocity at bit face to move those cuttings away, or I will destroy that hammer. I need annular velocity that can move those cuttings away from the face. And a 5.5 inch or 6 inch hammer at 5,000 psi is not going to last that long. Finally, as I get into these higher water tables, how do I overcome that? So proper operation requires enough volume in that compressor being CFM and PSI to get these functions to work. Suddenly we're at a 30 gallon an hour, 1600 CFM compressor. What is the cost there? What is our embedded carbon? Obviously, with DTH hammers, we need to think about cutting loads. I can over drill these. I can still cause deviation. I can still cause drag. I can cause bad fractures. And as we look at what we're saying right here, it's how we cause damage. And hammers are just as expensive, so we can have cost overruns there as well. So if I think about a well bore pressure, and this goes back to my oil field days, what is the right amount of PSI I can put at a bit face, bring cuttings up out of the hole without destabilizing? When I do it poorly, I induce my fractures, and that comes from the drilling method I use to my fundamentals to high solids in air or mud. If I can't get them out of the way of the bit face and I continue to penetrate, I'm causing hole destabilization and deviation. Another way that happens at the end of the hole, I have those reactive solids around that bit face or the top of the collar, and I can pull that hole in on top of me. What does the hydraulic head look like there? So formation damage, I always think of it as I'm trying to get quarters out of the hole before they start breaking down into dimes. But, I need to be able to get that product to bottom. I need to be able to get that trimmy to bottom. I need to make sure the hole is gauged. And the more surface area and the more cuttings that load up, the more damage I start doing. And that's when it takes me twice as much, or I have to go back in and chase that hole. So really quick, jumping into loss zones that Mother Nature has given us, but this is the bore field we have. How are we going to overcome them? We think about what type are they? Are they a seepage that I can block off with a super absorbent? Is it partial? Is it something that it's going to take a calcium spun fiber or bentonite to yield out? Am I going to cement that zone shut and re-drill it, or is it a complete? And as I think about it, we have the tools in our toolbox, but as we look at the impact, one, what am I shutting off down there? I should know this from my test holes. That's why I need more than just a couple, is understanding where those zones happen. At Ball State, it kicked our butt. And then as we started realizing the 3 or 4 sections we were in, we were going to have to change our entire drilling program. One piece was more surface casing. The next piece was going to a super absorbent. But my biggest concern as we start throwing things at this to try to get back on timeline, is it an NSF certified product? Is it cottonseed hulls, cedar fiber, paper? Am I creating a nutrient source into a solution cavity that feeds into groundwater? And later on, we're going to find out that we negatively impacted the local well field. And now that's why we have a wellhead protection area and we can't do any more geothermal in that area. I've seen that happen several places in the country. So again, lost circulation material, it's what can I use that's safe, effective, allows me to drill and allows me to grout, set loop effectively and grout effectively. When I combat these lost zones, I start thinking about what is my solids control? How am I getting those cuttings out of the hole? Where am I diverting those cuttings to? What is my drilling fluid properties? What is my foam properties? What does my cuttings look like in my air hammer coming out? How can I utilize a secondary method when I need to? What lost circulation materials? As we get into concerns, as I get state regulatory agencies all over the country giving me a call, some buffoon started a series called Ask Brock, what do they get concerned about? The utilization of non-NSF approved materials into groundwater zones. Though we are a borehole, we are still commingling with aquifers until we have that good, effective grout job. And they're concerned that the grout job's not being done effectively. So are we getting the trimmy to bottom? Are we having that good, consistent seal? Is it the right grout for the formation? Is there grout subsidence? Is there subsurface conditions limiting us to how we're going to? Cementitious mixes. Portland type 1L is kicking our butt in places when you can look at, we can have 14% limestone now versus, the 7-8%. We don't have the same standards as we had before we went to a low carbon cement. So there are water quality challenges there and mixing challenges. And again, they start thinking about microannuluses, improper drilling, from an engineering standpoint, large filter cake. Then we go in and we cement that with graphite, and suddenly it's shrinking on us. We have poor thermal transfer. So what have I learned in the last 22 years since Yordy and Sons on to Halliburton through where I am today? Yeah. What is my trust in my qualified contractor? What is my specified drilling method? And what is the driller's recommendations? Rob, hopefully he'll speak up in a little bit, but we need to trust in our qualified contractor that if they're bidding this with a method, they have an idea and a timeline. What are my test holes and representative samples? Test holes versus test wells? What can we learn from the municipal water approach? Municipal water, I have 2 test wells that are done that are my base for me to say what my performance of that well is going to be. Are we municipal water? No. But I'll tell you what, a bunch of our major engineering firms work on municipal water wells with a totally different department that have theories and geologists and hydrogeologists that we should be collaborating with. What are bore field and borehole specifications? From, man, a 400-foot hole is deep, let's put 2 loops into it, to 850 and 1,000 today. What is my equipment capabilities and limitations? And again, as we go from 500 to 650 to 850 to 1,000, that loop installation and that trimmy installation, and how am I positively displacing that thermally enhanced grout from the bottom of the hole out to make sure I have the best hole possible. And we have about 5 minutes. I really wanted about 10. Let's open it up to questions. And this was a lot. So again, I got to figure out how we can talk faster next time.
Great presentation, Brock. Thank you so much. I've unmuted Robert's microphone and allowed the camera as well. So if he wants to maybe say a few words, then we can go to questions. It's your call. You might
Let's open it
your
up to
screen.
questions.
Okay, I've got some that we can read here. Then you can unshare your screen if you like. There we go. Great. So Rajendra has a question. Sorry if I mispronounced that name. What is your deepest borehole and your largest bore diameter that you're currently drilling?
Oh, man, you got to ask the driller the favorite answer question, which is it depends. So for me, if I get into the lower Floridian, and depends on the type of um, project I'm on, but right now, I've seen some 8-inch boreholes to 1,000 feet for geothermal. We're trying to maximize the size of the borehole, the uphole velocity, what we can get in for product and grouting, and that comes back to hole specification. But when you get to that rig that can run a 6.5 inch, an 8.5 inch, or 12 inch, it's really just about time and the amount of cubic feet of material that we're removing out of the ground. If that's a hot rock geothermal question, let's take it offline and we can really geek out.
He's asked you personally, from your experience, what is the deepest and the largest diameter?
So during
question.
During COVID, I was working in Lake Wales and Frostproof with the Southwest Florida Water District on 2 lower Floridian wells, one at 3,800 feet and one at 4,200 feet, that started with a 30-inch hole and ended with an 18-inch hole. I've done a ton of municipal wells. I've worked offshore in the North Sea, so it's been all over the place.
Okay, very good. Ruben has a question, a comment, then a question. With higher production rates and deeper boreholes, we're hearing more anecdotes about borehole deviation, sometimes significant. How much of an issue is this, and what should be done as an industry?
I love the question. Borehole deviation is 100% dependent on the type of machine we're using, the bottom hole assembly. So as we look at the bit to the drill stabilizer to drill collars and the depth we're going to go, because if we look at a municipal water well in the AWWA standard, which means we have to be able to get a submersible pump or a line shaft turbine all the way down 1,800 feet, we have very limited tolerances there. It really comes back to, if I have the right rigidness structure starting and I'm not dependent on the pull down of my rig and my speed, I can slow that down. Now let's shrink that back, and I'm going to take a 70,000 pound pullback machine, 4.5-inch drill rods. I want to drill a 6-inch hole to 850 feet. And every newspaper article I see says these yahoos are taking a day and a half to drill this hole, or they're taking a whole day to do this, when we could drill 300-400 foot holes in the same day. Of course, it's taking 400 feet and on changes the solids content, the material we're moving out, the uphole velocity, the time between connections. There's plenty of things. So we're trying to catch up. And what happens as we start putting more weight, those drill rods flex. And those drill rods flex because when we do horizontal in oil and gas, that's that same I can't think of the name of the steel, but it's the same steel we're using for a 20-foot drill rod. It's just the degree of deflection we put on it.
Very interesting. I want to be considerate of everyone's time. It is half past the hour. Do you have a few minutes, Brock, to answer other questions, or do you need to take off? Okay, very good. Boss has a question here. Again, I'm sorry if I mispronounced your name. Are there established methods when you hit artesian flow? What if the contractor says, I can't handle all this pressure?
The artesian flow is something that is costly. And we've also had projects where State regulatory agencies have come in, and we have water coming up around loops. And depth to where that confining layer is and how we can shut it in is very important. When it comes to holding it back and weighting up, we use barium sulfate as a weighting material that has a specific gravity of 4.1. The great thing with using a barite material is it's reusable. So if we said we are going to do 10 holes, it's going to be costly. But the question is, do we case off that zone? Do we cement off that zone, or do we drill with a weighted drilling fluid and hold it back? And then we take that weighting material and we drill the next borehole with it with the proper solids control.
Okay. Very good. Well, thank you so much for your time, Brock. Fascinating presentation, and hopefully everyone got a lot out of this. Check out the recording if you want to watch this over. It should be online in the next few days. And I appreciate everybody's time today. Have a nice weekend. Any departing thoughts, Brock, before we call it good?
I think we're in a great place as an industry, and the more we collaborate as understanding our capabilities and limitations from a contractor side to the engineering side, and then realizing our neighbors are really, really impactful on what's happening to our success at these job sites. It's all about perception at the end of the day.
Very good. Thanks again. Take care.